Hello everyone. In previous class, we discussed about what is infinite bus bar, phase sequence indicator and synchroscope. पिछले वाली क्लास में हमने ये जो तीन टॉपिक है इनको स्टडी किया था. Now, in this lecture, we will study about the comparison between the EMF method and MMF method to find out the voltage regulation of alternator, salient pole as well as the cylindrical rotor alternator, जिसको हम नॉन सैलिएंट पोल अल्टरनेटर भी बोलते हैं. After this, we will move on the compare or comparison between the direct method to the zero power factor method. It is also known as the Portier triangle method. ZPF method को ही हम Portier triangle method बोलते हैं क्योंकि इसको हम एक ट्राइंगल ड्रॉ करके सॉल्व करते हैं. The next topic is the effect of change in speed, excitation and unequal voltage. जब हम दो पैरेलल जनरेटर पावर सिस्टम में यूज करेंगे या हम जनरेटर को इनफाइनाइट बस बार से सिंक्रोनाइज करेंगे, उस कंडीशन में अगर हमारा स्पीड, एक्साइटेशन और वोल्टेज जो है वो अनइक्वल हुआ तो उनके क्या क्या इफेक्ट हो सकते हैं पावर सिस्टम पे, उसको हम स्टडी करेंगे. And finally, the reference of this presentation. So in this lecture we cover all these topics one by one. हम ये भी देखेंगे कि कौन सी मेथड जो है वोल्टेज रेगुलेशन की वो सबसे अच्छी होती है टू फाइंड आउट द वोल्टेज रेगुलेशन. So let's start with topic 1. Comparison between the EMF method and MMF method. EMF मेथड को हम सिंक्रोनस इम्पीडेंस मेथड बोलते हैं और MMF मेथड को हम एम्पियर टर्न मेथड भी बोलते हैं. Okay, so this is the table of comparison between the EMF method or synchronous impedance method to MMF और एम्पियर टर्न मेथड. तो पहला लेंगे हम सर्किट डायग्राम. सर्किट डायग्राम दोनों मेथड का जो है वो सेम ही होता है, EMF मेथड एज वेल एज दी MMF मेथड. EMF मेथड को हम सिंक्रोनस इम्पीडेंस मेथड बोलते हैं. इसमें हम सारे पैरामीटर्स जो होते हैं मशीन के वो उनकी EMF क्वांटिटी को कंसिडर करते हैं. इन केस ऑफ MMF मेथड, इसमें हम जो अल्टरनेटर की सारी क्वांटिटीज हैं उनको हम MMF के फॉर्म में कंसिडर करते हैं. सर्किट डायग्राम दोनों का सेम होता है. So point number 2, test required. In a EMF method, open circuit test and short circuit test are required and measurement of armature resistance RA. But in case of ampere turn method, only open circuit and short circuit test are required. It does not require the measurement of armature resistance. Point number 3, procedure. The procedure to find out the voltage regulation by using the EMF method is simple, and MMF method also, it's a simple method. Accuracy of result. It gives high value of voltage regulation. Means synchronous impedance method जो है वो voltage regulation जो हमारा calculated है उससे उसकी value जो होती है वो हमें ज़्यादा मिलती है. और MMF मेथड में हमें कंपेयर टू EMF मेथड वोल्टेज रेगुलेशन एक्यूरेट मिलता है. Assumption. In synchronous impedance method, the armature reaction effect accountability is equal to IA into XL. In case of MMF method, IA into XL is treated as additional armature reactance drop. So the point number 2, the magnetic reluctance is constant and all voltage drop are considered as the part of EMF in case of synchronous impedance method or EMF method. In case of ampere turn or MMF method, all the voltages are expressed in terms of field ampere turns or all the voltage drop are considered as the part of field MMF. Point number 6, suitability. So the synchronous impedance method is suitable for all capacities of the alternator, and ampere turn or MMF method also suitable for all capacities of the alternator. Point number 7, the calculation involved. In case of synchronous impedance method, we perform open circuit test and short circuit test and draw the OCC as well as the SCC and calculate the value of synchronous impedance ZS is equal to VOC divided by ISC for same IF, means for same field current. XS is equal to under root of ZS square minus of RA square, and finally calculate the value of no load voltage E is equal to under root of V cos phi plus IA into RA whole square plus V sin phi plus minus IA into XS whole square, and find out the value of voltage regulation. So percentage regulation is equal to no load voltage minus of full load divided by full load voltage into 100%. For MMF method, IF is equal to corresponding EMF is found from OCC is equal to E, and find out the value of no load voltage, and finally find the value of voltage regulation. So in case of synchronous impedance method, the calculated value of voltage regulation is higher to the standard value. So this method is known as pessimistic method. ये बहुत ही important चीज है, कई बार गेट या जो कॉम्पिटिटिव एग्जाम होते हैं उसमें क्वेश्चन आ जाता है एमसीक्यू में, तो आपसे पूछ सकते हैं कौन सी मेथड जो है वो पैसिमिस्टिक होती है और कौन सी मेथड जो है वो ऑप्टिमिस्टिक होती है। तो जो सिंक्रोनस इम्पीडेंस मेथड है वो हमारी पैसिमिस्टिक मेथड होती है, क्योंकि जो वोल्टेज रेगुलेशन का रिजल्ट हमें मिलता है कैलकुलेट वाला वो स्टैंडर्ड वैल्यू से ज़्यादा मिलता है, इसलिए हम उसको पैसिमिस्टिक मेथड बोलते हैं। ऑप्टिमिस्टिक मेथड हम बोलते हैं एमएमएफ मेथड को, क्योंकि इसमें जो हमें वो रिजल्ट वोल्टेज रेगुलेशन का मिलता है वो स्टैंडर्ड वैल्यू से कम मिलता है, इसलिए हम इसको ऑप्टिमिस्टिक मेथड बोलते हैं। तो ये 2 पॉइंट बहुत ही इंपॉर्टेंट है। The next topic 2 is comparison between the direct method to the zero power factor ZPF or Portier triangle method. So this is the comparison table. Number 1 is circuit diagram. Circuit diagram is different for direct method as well as the ZPF method, or also known as the Portier triangle method. ZPF मेथड में हम 2 वॉटमीटर भी कनेक्ट करते हैं और 3 फेज इंडक्टिव लोड हम कनेक्ट करते हैं, जो कि हमारा वेरिएबल 3 फेज इंडक्टिव लोड होता है। इन केस ऑफ ZPF मेथड आर्मेचर वाइंडिंग के साथ हम 3 फेज वेरिएबल लोड कनेक्ट करते हैं। बाकी सर्किट डायग्राम सेम टू सेम डायरेक्ट मेथड जैसा ही होता है। Next, point number 2, test required. So in case of direct loading test is required. In case of ZPF method, open circuit, short circuit and measurement of RA, means armature resistance, as well as additional ZPF test is required for Portier triangle method. Point number 3, the procedure. Direct loading method is simple than the Fourier triangle. And the process to find out the voltage regulation by using the ZPF is complex than the EMF and MMF or direct loading method. Point number 4, accuracy of result. In a direct method, we find out the most accurate result. ZPF, we can also find out the accurate result. Number 5, assumption. Armature resistance value is assumed constant, that is the effect of temperature rise on armature resistance RA is neglected. In case of ZPF method, number 1, armature reaction MMF and leakage reactance drop are spreaded. Number 2, IA into RA drop and IA into XL drop are considered as EMF drop and IA into XA is considered as MMF drop और MMF क्वांटिटी, बिकॉज ZPF जो होता है वो कॉम्बिनेशन होता है EMF मेथड का और MMF मेथड का. पॉइंट नंबर 6, suitability. So direct loading method is suitable for the small capacities of the alternator and ZPF method is suitable for the large capacities of the alternator. Point number 7, calculation involved. In case of direct loading, only the voltage regulation calculation is required and we can find out the no load voltage or full load voltage and find out the value of voltage regulation in percentage form. In case of Fourier triangle or ZPF method, the Fourier regulation diagram is constructed and regulation is found. Point number 8, temperature rise of the alternator. Both the method we can observe the temperature rise of the alternator. Point number 9, determination of efficiency. So by using both the method means direct loading as well as the ZPF method, we can find out the efficiency of the alternator. So this is all about the comparison between the direct loading method and ZPF or Fourier triangle method to find out the voltage regulation of the alternator. The next topic is effect of change in speed, excitation and unequal voltage. हम देखेंगे कि अगर इन पैरामीटर में चेंज होता है तो सिस्टम जो है वो किस तरीके से अफेक्ट होता है. ओके, सो पॉइंट नंबर ए इज सिंक्रोनाइजिंग एक्शन. पहले हम देखेंगे कि सिंक्रोनाइजेशन हम कैसे करते हैं जनरेटर्स का, दो जनरेटर का या एक जनरेटर को हम इनफाइनाइट बस बार से कैसे सिंक्रोनाइज करते हैं और स्पीड, एक्साइटेशन और वोल्टेज चेंज होने से सिस्टम में क्या इफेक्ट होता है वो हम देखेंगे. सो कंसीडर टू सिमिलर सिंगल फेज अल्टरनेटर ऑपरेटिंग इन पैरेलल एट नो लोड. द मैग्नीट्यूड ऑफ EMFs E1 and E2 are equal. So this is for alternator 1 and this one for alternator 2. This is the per phase equivalent circuit. ये E1 जो वोल्टेज है ये जनरेटर 1 के द्वारा जनरेटेड वोल्टेज है. XA is called the armature reactance of the alternator 1 and RA is called the armature resistance of the alternator 1. Similarly alternator 2 के लिए बनाया हुआ है. These EMFs are acting in same direction with respect to the external circuit or load, but with respect to each other, these EMFs are in phase opposition. तो ये जो दोनों EMF है हमारा E1 as well as E2 जो यहाँ पे मैंने ड्रॉ किया हुआ है, this is called the E1 and E2. With respect to external circuit और load, दोनों जो होते हैं वो same direction में होते हैं, but with respect to each other, अगर हम दोनों की रिस्पेक्ट की बात करें तो दोनों एक दूसरे के अपोजिट होते हैं. When alternator are in exact synchronism, so E1 and E2 are in exact phase opposition, and since E1 is equal to E2, there is no current flow through closed circuit formed by two alternators. Next is a parallel generator theorem. So consider two identical alternator operated in parallel as shown in a figure. This is the alternator 1, same diagram जो अभी हम लोगों ने देखा है थोड़ी देर पहले, बस इनमें हमने X और R को कंबाइन करके Z इम्पीडेंस के फॉर्म में लिखा हुआ है. So the alternator 1 voltage E1 and alternator 2 generated voltage E2. So Z1 is equal to Z2 is equal to synchronous impedance of respective alternators, and ZL is equal to load impedance, or we can say that impedance of the load. The above circuit and parallel circuit using parallel generator theorem, Vt is equal to V is equal to IR होता है, R की जगह हमारे पास Z है, so V is equal to I into Z. Vt is equal to I into ZL. I हमारे पास चूंकि दो है, I1 plus I2, जनरेटर 1 plus जनरेटर 2 into ZL. अब I को हम लिख सकते हैं V upon R या V upon Z, तो उसी को हमने मॉडिफाई फॉर्म में किया हुआ है. सो इन ब्रैकेट I1 की वैल्यू है E1 माइनस ऑफ V डिवाइडेड बाय Z1 प्लस सिमिलरली I2 E2 माइनस V डिवाइडेड बाय Z2 इनटू ZL. अब E और V को हम सेपरेट कर लेंगे इक्वेशन में. सो E1 डिवाइडेड बाय Z1 प्लस E2 डिवाइडेड बाय Z2 इनटू ZL माइनस ऑफ V इन ब्रैकेट 1 upon Z1 माइनस ऑफ 1 upon Z2 इनटू ZL. So V in bracket 1 upon ZL plus 1 upon Z1 plus 1 upon Z2 bracket close is equal to E1 divided by Z1 plus E2 divided by Z2. If the short circuit occur, the current ISC1 and ISC2 will be delivered by respective alternators. The equivalent impedance will be 0. Means I upon Z0 is equal to I upon ZL plus I upon Z1 plus I upon Z2. Then V into 1 upon Z0 is equal to ISC, short circuit current, or V is equal to Z0 into ISC. Point number B, effect of change in speed. Suppose speed of the alternator 2 falls, then EMF E2 will fall back by phase angle alpha electrical degree. Still E1 is equal to E2. ये phasor diagram में हम देख सकते हैं. And this is again the equivalent circuit of two alternator connected in parallel. So E1 and E2 and exact phase opposition. There will be resultant EMF ER in the closed circuit formed by two alternators. This ER will circulate current known as synchronizing current. आपको ये भी है कि what is synchronizing current, तो ये synchronizing current जो होता है वो इस तरीके से हम define कर सकते हैं in the closed circuit or circulation current IC. So synchronizing current I as by is equal to ER divided by 2 into ZS. The current ISY lags behind ER. ये सब हमने अभी जो वेक्टर डायग्राम देखा है उसी को हम समझ रहे हैं. By the angle of phi, this angle is analogous to internal angle in synchronous motor. Armature resistance RA is very small compared to synchronous reactance XS, hence phi is nearly 90 degree. So the synchronizing current ISY is almost in phase with E1 and in phase opposition of E2. This means that alternator 1 is generating while alternator 2 is motoring, that is accepting the current because alternator 1 has to deliver current IS by. It's a synchronizing current. It can be said that it is loaded. Since load is increased, its speed falls down and alternator 2 accelerates due to the motoring action. Thus, system is restored to perform synchronism condition. Reverse will happen if the speed of the alternator 1 falls. In that case, it will act as a motor or the other alternator act as a generator. Point number C is effect of inequality of EMF, or we can say that unequal voltage. So in a perfect synchronization, synchronizing current IS by is 0 and E1 is equal to E2 in magnitude and in exact phase opposition. परफेक्ट सिंक्रोनाइज अगर हमें करना है अल्टरनेटर को, जो दो अल्टरनेटर हम पैरेलल में यूज कर रहे हैं, तो कंडीशन है हमारा सिंक्रोनाइजिंग करंट 0 होना चाहिए और दोनों अल्टरनेटर के जो वोल्टेज हैं वो एग्जैक्टली फेज अपोजिशन होना चाहिए और मैग्नीट्यूड में दोनों सेम होना चाहिए. Suppose due to any reason EMF E1 increase, that is E1 is greater than to E2, then the resultant EMF ER appear the local circuit of two alternators. This ER resultant EMF is in phase with E1. This ER send synchronizing current ISY in the local circuit of the alternator. The synchronizing current lag ER by 90 degree. Also, synchronizing current lags E1 by 90 degree and lead E2 by 90 degree. We know effect of power factor on armature reaction. So for lagging power factor, demagnetizing effect. So diagram A show the condition for perfect synchronism, and second is if the voltage is unequal in magnitude. आप देख सकते हैं यहाँ पे E1 का मैग्नीट्यूड ज़्यादा है और E2 का मैग्नीट्यूड कम है, तो अगर ये अनइक्वल होते हैं तो इसमें सिंक्रोनिज्म जो है वो हमारा सिस्टम का अफेक्टेड होता है. लीडिंग पावर फैक्टर प्रोवाइड स्ट्रॉन्ग मैग्नेटाइजिंग. द करंट सिंक्रोनाइजिंग or synchronizing current IS by lag behind E1, that is for alternator 1 power factor is lagging, so there is demagnetizing effect. The net flux is reduced. Demagnetizing effect क्या होता है? दोनों फ्लक्स एक दूसरे को कैंसिल आउट करते हैं. Therefore EMF E1 reduce. At the same time the synchronizing current IS by lead E2. So for alternator 2 power factor is leading and producing strong magnetizing effect, hence EMF is increased, or we can say that EMF E2 is increased. So the system is thus restored to a perfect synchronism. So the next is effect of change in excitation. This is explained in more detail with the help of following diagram. In this diagram, two alternators connected parallel with infinite bus bar. In this figure, the I1 is equal to current delivered by the alternator 1 and I2 is equal to current delivered by alternator 2. And IC is called the circulating current in the local circuits for both the alternators and bus bars. So two alternator इस फिगर में हम देख पा रहे हैं, दो अल्टरनेटर बस बार के साथ कनेक्ट हैं और दोनों के दोनों पैरेलल कनेक्टेड हैं. इस डायग्राम से हम समझते हैं कि अगर एक्साइटेशन किसी भी अल्टरनेटर का हम चेंज करते हैं तो क्या इफेक्ट पड़ेगा सिस्टम पे. So this is the figure 5. In this figure, two alternators operated in normal excitation. So for normal excitation, the kW of alternator 1 is equal to kW of alternator 2. Power factor also equal for both the alternators. So total kVA, or we can say that RkVA rating of both the alternator is same. So in this case, E1 is exactly equal to E2, or I1 is equal to I2. For the normal excitation, both the machine have equal RkVA or equal kVA, and kW1 is equal to kW2. The power factor angle of each machine phi 1 is equal to phi 2 is equal to phi, means दोनों का किलोवाट रेटिंग है वो भी दोनों का सेम रहेगा, और जो पावर फैक्टर एंगल है दोनों का वो भी सेम रहेगा. दिस कंडीशन इज शोन इन फिगर 5b, and E1 is equal to E2 and there is no circulating current IC is equal to 0. तो जब हमारा दोनों के दोनों अल्टरनेटर इस कंडीशन में क्या होंगे, प्रॉपर सिंक्रोनाइज होंगे, सो द सर्कुलेटिंग करंट जो है उसकी वैल्यू 0 रहेगी. Therefore I1 is equal to I2 is equal to I. Now if the excitation of first alternator is increased, अब मान लो हमने फर्स्ट अल्टरनेटर के एक्साइटेशन को बढ़ा दिया, which will increase E1, so that is E1 is greater than to E2, so the circulating current is due to the effective voltage in the local circuit. The voltage is E1 minus of E2 circulates current. अब इन दोनों के बीच में डिफरेंस आ जाएगा, तो जो डिफरेंस आएगा वही हमारा सर्कुलेटिंग करंट को क्रिएट करेगा. So the circulating current IC is equal to E1 minus of E2 divided by 2 into Zs. Where Zs is a synchronous impedance of each alternator, this current is superimposed on I1 and I2. Therefore, as shown in figure A, current by first alternator is I plus IC and the current of the second alternator is I minus IC. But the total current is I plus IC plus I minus IC is equal to 2I, as was in the first case. So the active power kW1 is equal to kW2 remain the same, but the reactive power and the power factor of each alternator are different, as shown in figure C. So the kVA1 is greater than to kVA2 and RkVA1 is greater than to RkVA2. kW1 is equal to kW2 and cos phi 1 is less than to cos phi 2, or phi 1 is not equal to phi 2 is not equal to phi. Hence the power factor of the first is reduced and the current is increased, but the power factor of the second is increased and its current is decreased. Active load is same, but the reactive load shared by each alternator is different. So the next point is E, effect of change in input to prime mover, change in steam supply or change in mechanical torque. Keeping excitation constant, and if the input steam supply to the prime mover of first alternator is increased, then its rotor advance in angular position as compared with second alternator. This position of the vector E1 differ to E2 by the angle alpha. So this is the power triangle diagram for change in input to the prime mover. It is therefore obvious that power of first machine is increased by E1 into IC per phase, and the power of second machine is decreased by the same amount provided by load is same. The current ISY means synchronizing current, that is IC, has no appreciable reactive components, and therefore there is no change in RKVA means reactive KVA. That is RKVA1 is equal to RKVA2 in figure C, and KW1 is greater than to KW2. So phi is decreased and phi2 is increased. So this is the equivalent circuit of two alternators connected in parallel. The E1 is called the EMF of first alternator, Z1 is called the synchronous impedance of the first alternator, and I1 is called the current delivered by the first alternator. So E2, Z2 and I2 indicate the corresponding quantities of the second generator. I is equal to total current is equal to I1 plus I2, and Z is equal to impedance of the load. V is equal to terminal voltage, that is bus bar voltage. So I is equal to I1 plus I2, or we know that I is equal to V upon Z. So the value of I1 is equal to E1 minus of V divided by Z1. Similarly, I2 is equal to E2 minus V divided by Z2. So V is equal to I into Z. Put the value of I. So I is equal to I1 plus I2 into Z. So this is all about the effect of changing speed, excitation, unequal voltage, etc. Now the next is a references of this presentation. So these are the references. And thank you for watching this video.